Round 4, back for more, right? Like I chose rounds because sometimes it does, just feels like a boxing match, right? It's like boxing with this physics. Can we get it? All right, so in this case, problem 2. A cheetah can accelerate from rest to a speed of v2 in time t. How far does it travel in that time? All right, can we take that and visualize it? We've seen this before. All right, build a good habit. All right, once you've made your picture, click yes, ready to move forward. All right, here's what my picture would look like. Hopefully yours matches. Start with a coordinate axis. Doesn't tell me what direction it's going, so I'm gonna just assume everything's going positive here. So this would be in the positive x direction. I'll say I start at some x equals 0. So there's where I start, x1, and I'm over here later at x2, over here at that position. How far does it travel in that time? That's what I'm trying to find out, right? What is my delta x? That's what I want to know. Delta x. Delta x. Now, notice, careful, this is not the velocity that I'm drawing, right? This is the delta x, the displacement, the straight line vector from x1 to x2. That's what this delta x represents, right? What do I know? My velocity at 1 starts at 0, and then over here, my x2 is moving faster in the rightward direction at some v2. If you don't include the delta x, not a big deal. I just put it in there to like say, hey, this is what we're trying to solve for right there. That actual displacement from x1 to x2. And that displacement would be the same, whether or not, right, I made this x equals 0 or I made that x equals 100. It doesn't matter, right? Just to have some fun, I'll just say x equals 100 meters, right? So I'm not necessarily trying to solve for x2. I'm really trying to solve for delta x, right? But most people, if you're using that darned table method, right, you're going to have to choose to solve either x1 or x2, or move x1 over to make x2 minus x1 make that delta x. Sometimes you do want to know final position. That's where you're solving for x2. In this case, I want to know displacement. How far does it travel in that time? So in this case, I know I start from rest, and I know I end up with a speed v2, so that I knew those, and it tells I would know how long. I would know how far does it travel in that time. Okay, so that's the picture. From that, you should be able to get the graphs and the equations. Give it a try. When you're ready, click that yes button. Okay, hopefully this will be more of a check for you, at least trying this, right? Well, good habit, right? Start at velocity 0. I end at a velocity that is positive, and it's bigger than what it was. There we go. Connect them with a straight line. There's my velocity. Acceleration, a couple ways. I'm moving in the positive direction. I'm speeding up. That means acceleration must be positive. Other way, velocity time graph. The slope of the velocity time graph provides information about the acceleration. The slope of the velocity time graph is positive and constant. So my acceleration from both methods is positive, right? There we go. Now let's say I'm starting to get a hang of this physics thing. I'd be like, okay, I'm trying to solve for displacement. Which graph would I start with to calculate displacement? Velocity or acceleration? Hopefully you say velocity. Otherwise you'd say acceleration and I would say velocity, right? But when you do the area of the velocity graph, that is displacement. So we get my delta x equals, what is this going to be? It's a triangle, so it's 1/2 times base, which is time, times your height, which is delta v. Huzzah! Why did I say huzzah? Maybe you know, trying to solve for displacement. I know the value of 1/2. In this case, it would tell me how much time is by, and I know what my change in velocity is. Do I have to do the acceleration graph? Not at all. Also, notice that's the exact same equation we had up above, right? And there's no other thing I really have to do here, right? Delta x 1/2 t times v. Okay. Yeah, let's apply to the demonstration. Good deal. Let's see, I want to do here. So I'm going to need my velocity time graph. Okay, mouse. So I don't want position, I just need my velocity graph right there. Notice I can just click right there and change to whatever I need. Eventually I'm going to need to do some sort of area calculation here. But yeah. Looks like I gotta start over. It didn't start at 0, though I could probably still do okay on this. Okay. Now I also could have measured that too, but I guess that would have been something extra there. Okay. Let's calculate first. Let's do a couple calculations. First calculation, right? Delta x is 1/2 t times delta v. Okay, so let's just say I want to know at, let's do 3 seconds right there. We'll start at this. So I have to do a couple things, right? Mouse. I need to see, when did I start? I started right about there. About time 1 second. That's convenient. Okay. So I started at time 1 second. All right, so t1 is equal to 1 second. All right, I'll just say t2 is equal to 3 seconds, 3.0. So that means my delta t here is t, that's going to go right there. All right, this is 2 seconds. All right, my delta v, right, v1 is equal to 0. So v2, so I need to know, well, what is my velocity right here at 3 seconds? That is 0.917, right, equals 0.917 meters per second. All right, so I plug all this in. I get 1/2 times t, which is 2 seconds, all right, times my delta v, which is 0.917 meters per second. There's a couple other ways I could do that as well, right? If I wanted to, I could start here and I can highlight over. Are you gonna let me highlight? There we go. I can highlight over to 3 seconds right there. And when I do that, I could see information down here, right? In this bottom left. The delta t is 2 seconds, and my change in y is 0.51. Oh, that's because I didn't start right there. It's just it went with the, there we go. So now I have a delta t of 2 seconds in 0.912, right? Which is roughly about where I was. Okay, so there's lots of ways that you can use this software to get those values rather than just using the examine. Right. So with this, run through your calculations. Maybe you've already done that because you're bored, right? 0.5 times 2, that's 1. So well, that's simple, 0.917. 0.917 meters is how far I've gone. Okay. So then, what I'll do? Well, there's 2 things I can do. One, I just said the integral of this, the area of this, should get me the area, or the displacement. So I do that. Ooh, 0.9107, right? That's not too bad. 0.910, 0.917. Guys, that's pretty good, right? It's not exact. I get it. I understand. But that's still pretty good. All right, other way we could do this, like let's see what the actual delta x is when I go to the position, right? So we started at 1, so I go from 1, I go all the way to 3 seconds. Out of the way. So I gotta come this way. Let's go to the auto scale. There we go. So I start at 1, and I can go to 3, go all the way up here to 3, and I end up with a delta y of 0.903. That's your displacement. That's about how far I went. If you wanted to do that, you might have missed that, right? I'm just talking about right down here in that bottom left. I know I'm pointing there, you can't quite see it, but if I move my cursor, there we go. 0.903, 1.99. The other way we could do this is we could look at the examine button. I can say at 1 second, 0.264, right? So x1 equals 0.264 meters, right? And then I can go to at 3 is 1.169, right? So x2 is 1.169 meters. So my delta x will be x2 minus x1. Run through this. 1.169 minus 0.264 equals 0.905. Right? So again, guys, I mean, doing the data, we're doing the analysis. It's all right here. It's just all, I think, really quite cool. Right? All right. I'm going to clear that. So you apply that to the demonstration, right? Again, everything just kind of worked out. I mean, 0.91, 0.92, 0.90, they're all within that ballpark. And so now hopefully you have a pretty good feel for if you're given the question that says a cheetah can accelerate from rest to a speed of 20 meters per second in 2.5 seconds. How far does it travel in that time? I hope you're pretty confident in giving that a try right now.